Okay. So good evening, everyone. Today we'll be presenting our capstone project entitled Tracking Technological Innovation in the Philippines, Uncovering Insights from Patent Data. But before we delve into our presentation, we'd like to share our GitHub repository. So it's at tinyurl.com/patent data. So again, tinyurl.com/patent data. So, okay, onto our presentation. So do you remember your first mobile phone? So in my case, it was the Nokia 3310. And back then, it had enough features. So you could call, you can text, but most importantly, you can play games like Snake. However, there was always the better phone, which in this case was my dad's. So his phone was colored. It had a camera. You can take pictures and videos. And, I just laugh at myself now because I always thought it was the better phone. But now the mobile phone has evolved so much throughout the years, and more powerful phones and features are released every year. So this really gets you thinking, what enables this cycle of innovation? Or more importantly, how can we quantify innovation? So on a macro scale, like countries or regions, patent output is used as an indicator of innovation. So some of the items you may have used in the past may have had a patent. So like the face mask you use when you go out or the alcohol you use when you enter the mall. But first, what is a patent? So a patent is a granting of a property right by a sovereign authority to an inventor for his or her invention. So in this case, the inventor fully discloses his or her invention in exchange for exclusive rights, such as the right to earn from your invention for a set time. So in this case, IPOPHIL, or the Intellectual Property Office of the Philippines, is the sovereign authority for the Philippines. Okay, so what would it take for a patent application to be approved? So there are actually 4 steps. Number 1, it has to be a technical solution to a problem. So it must solve a problem. Number 2, it must be novel. So novel means new. Number 3, it must have an inventive step. So the solution should not be obvious to an expert in the field. And number 4, it must be industrially applicable. So it should be easily manufactured or used. But what if your application does not meet the inventiveness requirement? So that was the third requirement. There is an option called the utility model. So the utility model is relatively cheaper and easier to obtain. However, there is a trade-off. So patents are granted 20 years of protection from the filing date, whereas utility models are only granted 7 years of protection. So let's try filing for a patent, for example. So let's say you invented something that revolutionized the writing industry. So let's say, for example, that all the pencils in the world look like this plain old pencil, and you invent the attached eraser. So let's assess patentability. So number 1, is it a technical solution to a problem? So yes, because you don't have to carry a separate eraser anymore. 2, it must be novel. So as mentioned previously, all the pencils in the world don't have attached erasers. So your invention is novel. 3, it must have an inventive step. So you use the metal strip to attach the eraser to the pencil. And number 4, it must be industrially applicable. So it's easily manufactured with the available tools. So let's prepare your application. So you decide for a patent or utility model. You give your invention a title, and then you fill in your personal information. Then you give your application to the IPOPHIL, or the Intellectual Property Office. They will be assigning a filing number and a filing date for your application. Next, on the back end, so they will examine your application if they will grant a patent or not. So at this time, they will assign IPC classes. So these categorize your application according to field, and they will also publish your application on the IPO Gazette. And finally, assuming everything goes well, your application is granted. So they will assign your registration number and they will record the registration date. So with all of that stuff, this is a very simplified overview of the application timeline. There's actually more to this. However, it's very convenient because all of this data is easily accessible on the IPOPHIL website. So in that case, this led us to ask, what insights can we generate about the patent landscape in the Philippines based on filing data on the IPOPHIL website?
Right. So we went with our typical data science process. So we have data web scraping, data cleaning, and feature engineering, exploratory data analysis, then machine learning, and then we'll wrap it up with our conclusions and recommendations, and probably some few words. So when we tried to explore the IPOPHIL website, we found out that the website was actually dynamic. So it had no unique HTML address when we navigate through it. So we used Selenium to automate the process, and we got around 100,000 published applications. Then we did some data cleaning, identified the duplicates from our scraping, deleted what was missing, And we also did some logical data cleaning, like taking out what did not follow the process of filing, publication, and registration. So for example, the filing date was after the registration, which does not make sense. So and after the data intensive cleaning, we separated the patents and utility models, and we got around 45,000 patents, patent applications, and around 17,000 utility model applications. So with our exploratory data analysis, we got the top three categories are chemistry, metallurgy, with around 23,000 filings. So the likes of pharmaceutical inventions, and then followed by performing operations, transporting, and human necessities. And our top applicant goes to the Procter& and Gamble company with over 900 applications. And interestingly, just recently, P&G announced their highest US sales in decades, despite the pandemic. So according to World Intellectual Property Organization, Philippines ranks fifth in Southeast Asia with around 529 patents in 2018. However, our data shows 429 only, and this discrepancy could probably be because of our data cleaning. Moving on, when we played around to the daytime data that we had, we thought of applying linear regression with the number of utility models per year. But we only had zero point 0.5 as our R-squared score, which means our model is not a good fit.
Okay, so next we actually wanted to counter check IPOFIL's average processing time. So the processing time is the difference between the registration date and the filing date. So this more or less represents the wait time for an application to be approved and granted a patent. So with the features that we engineered, okay, first we'd like to share that IPOFIL claims around 3.9 years of processing time. And we compared it with the data that we engineered. So this is the histogram of the processing times for patents registered in 2018. And the median that we got was 1,402 days, which is quite close to the claimed value of 3.9 years or around 1,423 days. We did the same thing for utility models. So according to them, processing time takes around 7.5 months. We plotted a histogram of the processing times for utility models in 2018, and the median that we got was 223 days, which was close to 228 days, which they claimed. So speaking of statistics, if you look at the IPOFIL website, the official statistics on the IPOFIL website unfortunately paint a very sad picture. So while patent filings by local applicants are generally higher than foreign applicants, so the light blue bars are for resident applicants, the patent applications granted for residents per year is very low. So as you can see, the dark blue bars, which are the non-resident applicants, tower over the resident applications granted. Whereas for utility models, so more residents file for utility models, and a lot of them are actually approved year after year because they're actually quite easy to obtain. But then this data really gets you thinking, what if some of those utility model applications were patentable in the first place? So what we did was we used classification algorithms based on features generated during the application process to see if an application is a patent, potentially a patent or utility model. So we have IPC class information, such as categorical information, so if it's category A, B, or C, and numerical information, such as the number of unique classes. We screened the classification models and focused on the one with the highest accuracy. So that would be the AdaBoost classifier. We use 10-fold cross-validation to check if our model is optimized enough. So the standard deviation is quite low from the mean performance metric of the 10 folds. So the model more or less has been optimized. And so these are the stats of our model. So the overall accuracy is at around 81%. And the model classifies patents more accurately than utility models. However, maybe we'd like to focus on these 24. So these are 24 actual utility models, but from our algorithm, they were predicted as patents. And it gets you thinking if they could have been patents. But we do admit that our model is quite simple, so we leave that as a future recommendation. Speaking of other recommendations, we have NLP to assign IPC classes to an application. So what we can do is we can vectorize the titles, correlate terms to categories, and we can finally train the model to classify these applications.
And in this time of pandemic crisis, definitely the Filipinos are not one to miss out on opportunities to be creative, to be inventive. And this is proof that Filipinos have a lot of potential to innovate. So to our fellow Filipinos, let's keep our creative juices flowing. And maybe it's time we share and we also take ownership with our inventions. And who knows, our Filipino inventions could change the world. Together, let's shape our new normal with more inclusive innovations. Thank you.
Thank you very much.